Welcome, everybody, to the Simon Center. It is a great pleasure to host the La Pietra family's lectures. This has been a big series of very prestigious lectures that happen every so often in the Simon Center. But I just wanted to let you know that these are all sponsored by the La Pietra families, and they're actually extremely good benefactors, not only to the university, but also to the Simon Center. In fact, this hall is actually named after them. So, thanks to them, of course, we could bring Professor Christopher Llewellyn Smith to give us the La Pietra lectures. Yesterday, he mesmerized the high school students about the energy problems in the future. And today, he's going to mesmerize you with something which is kind of a miracle. Perhaps we should have this talk in Christmas, because it seems to be the Christmas miracle, to be able to do science at a sophisticated level in the Middle East, where people somehow have a hard time getting together or doing something together. So I could spend 15 minutes telling you about all the great things he's done, not only in basic science, but also in making sure that important things in basic science, like the LHC and other things, have happened. But for that, you can go to our webpage and read his biography. I prefer to leave you with Chris to have a nice presentation on SESAME. Please.
Thank you. Thank you very much, Luis. So SESAME is an acronym which stands for Synchrotron Light for Experimental Science and Applications in the Middle East. And a little bit later, I'll try to tell you what synchrotron light is and something about the science that it can do. But also, of course, SESAME has a meaning of opening doors in many languages. This is the SESAME building. Nothing remarkable about that. I'll open the door later and show you what's in it. These are the SESAME members, and there's something very remarkable about that, because it includes, let's say, two pairs of countries which have no diplomatic relations, Cyprus and Turkey, and also Iran and Israel. Iran doesn't recognize the existence of Israel. By the way, it's an intergovernmental organization, so it's the governments that belong. And I think that the SESAME Council is the only body outside the family of United Nations organizations in which representatives of the Israeli government and the Iranian government are sitting in the same room. And in Iran, when they joined, this wasn't something that some bureaucrat thought, well, this is good science, let's just join without telling anybody. They had a debate in the parliament. And they voted, I think it was 167-6 in favor of joining this organization. Now, in my career, I've been associated with two organizations which were set up under the umbrella of UNESCO, the United Nations Educational, Scientific and Cultural Organization, and have similar aims in some sense. The first is CERN. And you see here, this is the footprint on the surface of the Large Hadron Collider. That's the runway of the airport. This is 27 kilometers, 17 miles. This is SESAME, so it's a completely different scale, and the scientific goals are totally different. But they were born with the same ideas. The idea of CERN first surfaced in about 1949, when two ideas came together. In the subject of particle physics, as it's now called, the experiments were done by studying collisions of cosmic rays, the particles flowing in from outer space, and Europe had really been in the lead in this field until the late 1940s. But at that date, it was clear that in this country, large accelerators were being built which were going to take over because they could produce more particles at high energy in Berkeley, first of all, and then down the road here at Brookhaven. So the physicists in Europe said, if we want to stay in business, we're going to have to build these large accelerators. We can't afford them on our own in each country. The only way we can do it is collaborating. And this came together with the ideas of some rather far-sighted diplomats and scientific administrators who said it'd be really nice to find a project in which we can see if the countries that have recently been fighting and in conflict, the UK, Germany, France, Italy, can work together peacefully. And that was the way CERN started, very deliberately with two aims. Now, it's the same thing in SESAME. There are these two aims. I guess the difference is that when CERN was founded, the countries had recently been in conflict. In the Middle East, they still are in conflict. UNESCO has as its sort of byline, science for peace. I rather dislike that phrase. That sort of gets the idea, oh, let's go and do science for peace. These ideas, I'll talk about in a minute, about how a project like SESAME and indeed CERN can bring people together and build bridges between diverse peoples. But it's got to be driven first and foremost by science. If SESAME is a good a first-class scientific facility, the hotshot scientists from around the region will come there, they'll work together, they'll get to know each other. If it isn't, they won't. It's as simple as that. Now, before I say something about SESAME, I would say a little bit more about CERN and give you some examples of ways in which it's built bridges. So it was the first intergovernmental organization that Germany joined, the new Germany, and when you go back to then new, to the archives, you find they're very much on probation. Is Germany going to be a democratic country or not? And thank God we know the answer is yes. It was the first place that Germans and Israeli physicists could meet after the war. It pioneered collaboration with the Russians during the Cold War. It was one of the first organizations to work with China. It's played a role for back channels in the arms negotiations of hosting meetings of the experts on each side who often already respected each other because they knew each other's scientific papers, but they hadn't necessarily met. And when the discussions were stalled in Geneva on one occasion, one of my predecessors as Director General of CERN hosted a dinner where the scientists without the bureaucrats got together and basically sorted things out. And it's had an open-door policy for Eastern European countries during the Cold War. I think the experience of CERN that I hope will be replicated, in fact already is being replicated at SESAME, I can best illustrate by giving you an example. And the example is that of a Pakistani physicist, Hafiz Hourani, maybe some people know him, and he told me he wanted to bring a group of technicians to CERN from Pakistan to work in the CMS experiment, one of these huge experiments at CERN. And the technicians realized that there were many Israeli groups in CMS. And they said to him, we can't come. These people are devils, we can't work with them. And he said, you're damn well coming anyway. And after 3 months, they came back to him and said, you know, those people, they're pretty good technicians, and actually they're quite nice guys. So I'm a great believer in the idea that people who were initially very suspicious of each other's cultural views, religions, politics, or whatever, if they develop professional respect, that sort of breeds tolerance. You think, this guy's such a good engineer, and I can see that. I can't dismiss his other views totally. I've got to listen to him and take him seriously. And this is what we hope will happen at SESAME. In fact, I think already is happening. It's not going to solve the problems in the Middle East, but it can help if we've got a generation of young people, some of whom have never met people from the other members of SESAME, coming together and working there. Now, SESAME, like CERN, is going to be a user organization. That's to say, a very small staff. The users based in Cairo, Tel Aviv, Baghdad, or wherever, who will come periodically to carry out measurements there. Like CERN, and I couldn't resist showing you this map. These are where the users of CERN come from. Really quite remarkable. From a small organization to begin with, starting in the 1950s, this colossal number of users from around the world. It's really become a truly global project. Now, back to SESAME. SESAME is a third-generation light source. I'll explain what that is in a minute. But for the moment, think of it as an extremely bright flash lamp coupled to a number of microscopes. And it's a flash lamp where you can tune the wavelength of the light so it's appropriate for looking at matter from the scale of human cells down to atoms. And therefore, it's become a tool, essential tool in parts of biology, medicine, materials science, chemistry, physics, even archaeology can be used to do non-invasive testing. So SESAME is first and foremost is designed to foster science in these areas, and through fostering science, foster development. But of course also has this goal, that's what interests the people outside the region, of bringing people together. Here are the members, and there are a number of observers. I'll say something about their role later. So here's a map of where it is. Here somewhere, yes, this is the King Hussein Bridge. We Brits call it the Allenby Bridge, which from Sesame to Jerusalem, if there wasn't a frontier in the way, it's about an hour and a half's drive. And actually, Israelis are not allowed to cross this bridge. If you're a foreigner, you can cross the bridge as a tourist, but Israelis cannot. But we have a special agreement when Sesame was founded that people coming to Sesame can cross that bridge. And when Sesame was opened 2.5 weeks ago, a busload of, I think, 25 or more Israelis came over that bridge to the meeting. Now, there are some 60 light sources in the world, probably about 50 synchrotron light sources, but there are other light sources, types of light source, but none in the Middle East. So it's really fulfilling a need. The BRO program makes synchrotron light ideal for building scientific capacity, and international collaboration is the obvious way to build such a thing. There are countries which could afford to do it. And by the way, I should come back later to why there's a gap in that map. Why are none of the Gulf countries in there, the ones with the money? There are countries that could afford to build their own. The Iranians are thinking of doing it. But they probably don't have the science base to justify doing it. And as I said before, it's going to be a user facility. Now I'll tell you, those who don't know, something about synchrotron radiation. So if you think of a charged particle, suppose my fist is an electron, we know that if you bring up another electron, it's repelled. You learn this in high school, and you bring up a particle with the opposite charge, it's attracted. So there's some sort of force field surrounding an electron, just sitting there. But if I shake the electron up and down, the force field can't respond out here somewhere instantaneously, so some of the energy that's stored in that force field gets radiated away. And that's how a light bulb works, basically, or a radio. You just shake electrons up and down in a wire. Some of the energy in the field gets shaken off and radiated. Now, if we think of an electron, if it moves along uniformly in a straight line, the energy in the force field just moves with it. Nothing happens. But if you bend it in a circle by putting a magnet here, as in an accelerator, it's the same thing. The electron's trajectory is bended, but the field here cannot respond and turn the corner instantaneously and keep in the same position, so some of the energy is radiated. So all the way around a circular accelerator, there is light coming off tangentially. And as the energy of the accelerator gets higher and higher, this cone of light gets narrower and narrower and goes down to shorter and shorter wavelengths, so we can look at smaller and smaller samples with it. Now, accelerators are actually not perfect circles. They have straight sections in them, where you put the particles which put back the energy, because energy is lost by the synchrotron radiation, so you have to keep pumping energy in, pump it in the first place to get it up to almost the speed of light. And then you have to keep pumping in energy to replace the energy lost in synchrotron radiation. Sesame is a third generation source, which means it's got deliberately straight sections in which you can put things called wigglers and undulators. And you can think of those as magnetic bumps in the road. So the electron comes around, and it's sort of made to wiggle sideways. And every bump, it shakes off a bit more energy. And from successive bumps, the energy can add up. So it can get much more intense. And for those who are the scientists here, if you have a wiggler, it adds up incoherently. If it's an undulator, it can add up coherently. So this is a third generation source. You can get very, very intense light. Now, this is a picture inside the Sesame Hall. I'll show you the real thing in a minute. This is concrete shielding here, and it houses the accelerator and the storage ring. The storage ring is 133 meters in circumference. So there's a little pre-accelerator, there's a booster accelerator, and then the electrons are zooming around here, and light comes out in these intense cones through ports in the walls here, and there are devices called beamlines, which are a series of mirrors, basically, which select the light at the wavelength you want, different for different experiments, and focuses it on the samples that you want to study. Now, for the experts in the audience, these are the parameters of the machine. But I think for the non-experts, not so interesting. Let's just skip that. So what is the status of this project? It's faced many, many difficulties. But I want to stress there have been some political difficulties, and I'll come back to them at the end. But almost all the difficulties have been financial. These are countries whose budgets you can't see with a microscope, and they find it very, very difficult to pay. But it is now complete, and the beams have been stored and accelerated about just over a month ago to the full energy of 2.5 billion electron volts. Throughout, there's been a vigorous training program preparing the people who have built SESAME, but also the users, which has already brought benefits to the region. We've been losing staff. We've put people to, we've had a lot of help from Synchrotron Labs and others around the world. We've trained young people. They've come back to work at SESAME, and they're very good, and they get job offers. And some of them leave to the US or Sweden or whatever, but others move to high-tech jobs in the region. And that's good. It's not good for SESAME, but that's part of the purpose. We're bringing high technology to the region, training people who move off in the region, but some of them stayed and built it. The program will begin later this year, but initially with just 2 of these beamlines. It can go up to many more, and minimal supporting infrastructure. There was an opening by the King on the 16th of May, about 300 people, a Director General of UNESCO, the IAEA, ministers from around the region. It was a complete nightmare. The protocol, the security, you can't believe how difficult it was for a bunch of people who've never done anything like this. So I found myself being asked to answer trivial questions. Actually, at 9 o'clock at night before the opening, I was on the floor in the photocopying room trying to unjam the photocopier so we could print the program. But somehow it's got there. It is opened and it is working. I'm going to discuss the challenges later, but now I want to give you a photographic history and tell you something about what SESAME will do. So it's a convergence of 2 ideas. To build a light source in the Middle East. The person who first suggested that was Abdus Salam, a Nobel laureate, whose name will be known to many people there. I knew him well, actually. A great visionary, a great scientist. And in the early 80s, he wasn't thinking of something that brought in Israel, I don't think, but he was thinking of something in the Gulf. He said, Arab science from the golden age 800 years ago of Arabic science and Islamic science has fallen behind. It'd be really great to have a synchrotron here. And this came together with a group called the Middle East Scientific Cooperation Group, which had been deliberately looking for projects that would build bridges. And this is a picture of a meeting that happened in Dahab in Egypt. The chair of that committee was Sergio Fubini, who some of you will know. And there he is with the Egyptian higher education minister. And at that meeting, Eliezer Rabinovich, who's very dim in this photograph, but you'll see a better photograph of him in a minute, he and Venice Guda stood up and they took what they described as an official stand, saying we want to foster Arab-Israeli collaboration in science. So it's a very important meeting. There was a thunderstorm during, and there was a small earthquake during it. I don't know if that was significant or not. Now, those 2 ideas came together in, I've gone too fast, in 1997, when the late Gus Voss, who was a very brilliant accelerator physicist from DESY in Hamburg, and Hermann Winnick from Stanford, were on the advisory committee for the Berlin synchrotron. And it was being dismantled, replaced with a new one, and they had the idea, I think knowing nothing of this previous history, hey, why don't we try to persuade the Germans to give this device to people who would rebuild it in the Middle East. And I think if it hadn't been for the previous existence of the collaboration group, this would have probably been stillborn, this idea. But as it was, the idea fell on fertile ground. There was a group of people looking for projects, and suddenly there was a big project. They talked about synchrotron radiation, but it was really, they would negotiate, this group, the Middle East group, would negotiate an agreement to use the synchrotron elsewhere. They took the idea to Herwig Schopper, a former Director General of CERN, who said, if you want to do this, you need some big, widely recognized and respected body, UNESCO, and he took it to Federico, I've spelled his name wrongly, who in 1999 held a meeting of potentially interested parties in Paris, and an interim council was set up. In 2000, there was a competition to house the project, and there were actually, I think, 5 different bids, and Jordan made the best offer, and it's a wonderful site. It's one of the very few countries in the region which will offer visas to everybody else, which is one of the nightmares. When we try to hold meetings in different countries, you can't do it, because most of them are not giving visas to the people from the other ones at any moment. And in 2002, the idea of just rebuilding the Bézi 1 machine was abandoned, although parts of it are still used, and I'll come back to that. Now, the role of the idea of using the German machine, it's a peculiar one in a sense, because without that idea, this would never have started. People just say it's too expensive. There's no way we can build a synchrotron light source from scratch in the Middle East. So this idea got it going. But it was a dumb idea, because it would have been a second-class facility which would not have attracted the best people from around the region. So it got it going, but in 2002 it was realized that's not such a great idea, forget about it. So it was agreed to build a new machine without any agreement on how to pay for it. And in fact, the members had joined on the assumption we won't have to pay anything except the manpower to rebuild something that exists. So we're in the position of having designed a rather ambitious project with no idea where the money was coming from. I'll come back to that in a minute. Groundbreaking in January 2003, that's Herwig Schopper, who was the first president of the council. That's the King of Jordan. That's the then Director General of UNESCO. This is Khaled Toukan, that's Eliezer Rabinovich. You can see him a little bit better there. That's Khaled Toukan, who's been the director. Khaled he's a very clever guy. He's an MIT graduate in nuclear engineering, I think, but he's always had other jobs, which has been good and bad. He's close to the seat of power in Jordan. Without him being involved, this could never have happened. He's one of probably a handful of 4 or 5 people you can truly say without him it wouldn't have happened. But when I got involved, he was the Minister of Education, all the way from grade school up to university. So he didn't have any time to spend on this project. Then he was the Minister of Energy. Right now, he's the Director of the Jordanian Atomic Energy Authority. But nevertheless, he's been a crucial figure. Then the building was built. And in November 2008, it was opened. You can see me sitting here. And it was Herwig Schopper had asked me to take over. But we'd agreed I would take over the day after the opening of the building, which I did. Now, I want to talk about 2 things that persuaded me to take over. I said, first of all, I'd like to go out and see the facility and talk to the people there. And I met this bunch of kids, most of whom are still there, actually. These were young people who'd been trained in Europe with funding obtained by SESAME, who'd returned to the Middle East to build SESAME. I'm pretty sure that without SESAME, those people would have been gone. They wouldn't be in the Middle East now. And they were really inspiring, and I felt, if anything I can do to help these people, I want to do it. And the other was Eliezer, actually, who flew to England, and he twisted my arm, said, you've got to get involved in this. He's a string theorist. I'm not sure he actually knows what a synchrotron is, but don't tell him I said that. And Eliezer said to me, as a string theorist, I work on parallel universes. I was always curious about what a parallel universe was like, and now I know. I'm living in one when I go to SESAME meetings, working hand in hand with our neighbors on a common goal, bringing advanced knowledge to the region. And he said to me, I never expected in my life to be sitting around the table with our neighbors doing something positive. And I thought that was a very beautiful statement, and it was one of the things that got me involved. Now, I inherited an empty building. We'd opened this big building, which you've seen from the outside, but with no idea how to fill it and no plan of how to fill it. And we couldn't make a plan because there was no money. So the first thing I did is say, we're going to have to make a plan, but how can we make it with no money? And I decided the only thing we could do is we'll write a plan in which it says explicitly, this plan for building this facility is based on the assumption that funds will be available as and when needed. And any delay will just delay the startup. And we knew already that was wrong, because if we'd had the money then, we would have already been building. But there was nothing else to do. And very remarkably, that plan has been followed. Albeit much delayed. I think, I didn't check, it foresaw the machine starting in 2014, and now we're in 2017, and it foresaw many more facilities at the beginning. We've had to abandon a lot of things. But the breakthrough came in March 2012, when actually the Israelis started this. They said, look, I should say that the funding, my predecessor told me we need $16 million, and I'm pretty sure that the European Union will provide this. Now, I know something about accelerators, as indeed did my predecessor, and it was clear to me that 16 million was absolutely wrong. And we reassessed the cost, and I thought it was something like 35 million. Also, I was not convinced that the European Union was ready to help us. Anyway, you can't go outside and say, give us $35 million. The first question is, what are you doing for yourselves? So it was clear to me we had to get the members to do something. And the Israelis said, we will put in $5 million, provided 4 other countries do the same. And we convened a meeting in Amman. That was the only time I've been in a meeting with a small room, actually, in the basement of a hotel. I guess it was in the basement for security reasons, with a ministerial level meeting of the Israelis and Iranians. It was quite tense, actually. The Iranians didn't want to shake hands with the Israelis, and they didn't know who I was, and they were avoiding me until they realized I wasn't Israeli, and they started shaking my hand. The problem was that the agreement, I see I've spelled sesame wrongly there, the agreement was they come to the meeting. I asked all the members, and 5 agreed to show up, but you only see 4 there. And the reason was that the night before the meeting, the Egyptian government changed. So I'm often asked, what was the impact on Sesame of the Arab Spring? And there was indirect impact, that was financial chaos in the region, but the only direct impact was when we got to the meeting, people saying, we're coming because you've got 5 countries saying they're willing to discuss this, but only 4 showed up. And subsequently, the Egyptians said, well, what we agreed is let's start anyway, and we hope Egypt will join in the next year, and if they don't, we'll reassess the situation. And they never have joined, because we've been close to getting them joined 3 or 4 times, and whenever we've been close to it, they changed the government. Still hoping they'll come in. The other problem is that Iran actually hasn't paid because of sanctions, which are supposed to be over, but they are not. You try getting money in and out of Iran right now, it's sort of impossible. However, once we had this, we said we've got $20 million because we didn't know that Iran would not be able to pay, and we're looking for Egypt to come 25, then we could start talking to others. The European Union said, we will help you, but we don't really trust this bunch of amateurs in the Middle East to build this machine. We'd like to involve CERN. How would it be if we give the money to CERN to build just the magnetic system of the main ring, and they will run the construction of the magnets, the procurement, in collaboration with SESAME. And that was a fantastic agreement, because CERN put hundreds of man-hours, which they never charged, and they haven't admitted to the members of CERN who might complain. It wasn't really what they're funding CERN for. And they took a lot of the young people from the Middle East to CERN, which they loved, and they learned a tremendous amount. So that worked very, very well. And that success encouraged the Italians. And the Italians gave us €1 million in 2014 to procure cavities. And further Italian contributions followed. And up right now, they're up at today's exchange rate, it's about $3.6 million. Now, let me flip through. This is the hall in 2012. At that point, that was before we'd got the money to put anything in there flowing. So the only thing that happened, there was this large empty building, and the Jordanian royal court, the king has a slush fund he can use for things, and had paid for the concrete. So this was empty concrete shielding. to prevent radiation damage, but there was nothing in there. Now, notice this beam across here, horizontal beam, fisheye camera, so it doesn't look exactly horizontal, but I can tell you it was horizontal. And I'll explain in a minute why I'm showing you that beam. So that was the hall again, same picture. And this is the booster, which this is the, first of all, there's a small accelerator starts the electrons going, you put them in this booster synchrotron, and then they're put into the big machine. And this is built with components that came from the German facility. That's the booster in November 2013, and then disaster struck. So that you probably remember that the roof of the building was white, and it is white today, but until November 2013 or December, it was blue, in fact. And then in December, there was an unprecedented winter. It even snowed in Cairo and exceeded the specification for the roof loading. A lot of snow and ice accumulated, and the roof caved in. And now you see this beam, which was horizontal, high up at the top of the ceiling in the previous photograph, collapsed. And there was a tremendous row because it was clear the building hadn't really, it was partly the design, but it was also the building, as often happens, the contractor had cut corners. He claimed we'd been misusing the crane, and there was a big argument about who was responsible for this. But here's the caved-in roof after the stuff at the top had been taken off, and you see this sagging beam. And then here, and of course, the scientific press that's been following this project, they couldn't resist showing this picture with open sesame on it. But remarkably, the booster was commissioned under the open sky. It was incredible, the response of the team. It took a long time because of the fight about who was responsible. But in September 2014, it reached the full energy, 800 million electron volts. It was then the highest energy accelerator in the Middle East, overtaken in January this year by SESAME itself. And here's the new roof fully in place. Now, so CERN was to build the magnets or procure the magnets, and this is the first complete set of magnets. These are magnets that bend the beam around in a circle. These are magnets that keep them focused in a tight bunch. This is the first complete cell of 16 cells altogether assembled at CERN. And you can see parts coming from all over the place, from the observer members and from some of the members of SESAME. This is the installation, just flashed through this just over a year ago, beginning of last year, putting the magnets in. And in February 2016, the first Girder magnets vacuum chamber installed. Of course, there's other things you have to do. You have to install all the vacuum, the cavities. These are the things that sort of radio transmitters, if you like, which put in electromagnetic energy to keep the electrons, speed them up in the first place and keep them going when they lose energy from synchrotron radiation, which were provided by the Italians. Then you have to deal with the cooling system. But here, in November last year, is the complete machine assembled. Ready to go, but it turns out there was still some question. You've got to take the electrons from the smaller accelerator, the bigger one, the transfer line had to be put in, but then success. The 11th of January, I won't try and explain this, but this is a spot, shows the beam having come right round, and here is the team, led by a European, Erhard Hüttel, but the other team, some of these were actually in that photograph I showed you from 2007 of the young people who went back to the Middle East to build SESAME, and the design energy was reached on the 27th of April this year. Not at the full current yet, we're still winding the machine up. And this basically is the team. Actually, the staff altogether, I think it's about 48. 50% of the women, well, more, were absent on that day. I like to say that SESAME will be an island of equal opportunity in the Middle East, but so far it's been engineers. I think it's changing with science. And here's the opening. This is the King of Jordan. This is myself with Khaled Toukan, the director. Here's the king, and on his side here, this is Irina Bokova, who's the Director General of UNESCO. This is Carlos Moedas, who's the European Commissioner. This is Rolf Hoyer, who until 2 years ago was the Director General of CERN. And he was supposed to take over from me after the council meeting, which took place the day after this photograph was taken, or halfway through the council meeting. But actually, just after this photograph was taken, he heard that his mother was very ill and he had to go back to Germany. So I've sort of still been doing the job to a certain extent, but in principle I've handed over. This is Princess Samaya, who is driving force of science. She's a brilliant lady, first cousin of the king in Jordan. And this is Fabiola Gianotti, the Director General of CERN, who some of you will know. And back here is the Director General of UNESCO. And this guy was not supposed to be in the photograph, and I'm ashamed to say he's a Brit. I mean, people were told, you're supposed to come up for this photograph, and he just took it upon himself to come up also. So now let's get to the science. So you can do a lot of different science with synchrotrons, and these beamlines, actually SESAME is the other way around, so sort of a bit disconcerting this. The beam's going around the other direction. It's not that you have one beamline for medicine, another for archaeology. The beamlines are chosen by the wavelength. But this just indicates a very large number of things you can do. And the people who work at synchrotrons tell me that one of the interesting things is they may be there at night taking data, and they start talking to the people on a neighbouring beamline or on the same beamline, and they learn a lot. They learn a lot in a human way, talking to their other people, but they also learn a lot of science. So these light sources, as I said, are equipped with beamlines which focus the light on samples that we wish to study, and each beamline can support several experiments in series or in parallel. Initially, when we wrote the long-term plan, I think we said we were going to start with 7, but we've just got to get this started. So we're starting with 2. One is called BASIMA, Beamline for Absorption Spectroscopy Environment Material Applications. It means a smile in Arabic. And the other, EMIRA, the infrared beamline, means princess. There are 2 more coming, a material science beamline and a macromolecular crystallography beamline. And those are, one of them will be going next year, the one the week after, and 3 more coming up after that, of which we think we have the funds now for one of them, actually. Now, just this is for experts. I think I'll skip that. It tells you the energy of the beamlines. But I'll just say something about the first beamline to be operating, BASIMA, because it illustrates 2 things. First, this beamline is built with components which were given to us by the European Synchrotron Radiation Facility in Grenoble. It's actually a German beamline initially, and they said, we are building something different. You can have these components. They've had to be rebuilt and adjusted to fit the circumstances of SESAME. And the other of the first beamlines is new, but some of the beamlines at the beginning are made with used equipment. I think the interesting thing, however, is it will have, the Italians have built for us a detector which is going to have a sensitivity at least 50 times higher than any other in the world for this purpose. So there are some things which are really state-of-the-art, and I'll give you another world first later in this talk. Just a word about the science. Some of it will be of regional relevance. So there's a group which has been studying pollution in the Jordan Valley. They're looking at heavy metals in the soil. It's not so easy to get close to the Jordan for security reasons, but they've somehow managed to do it. And they're using the synchrotron in Trieste, the electrosynchrotron in Italy. But that work will move to SESAME. I mean, they're studying something of it's a public health hazard, this is dangerous pollution, and they're tracing, what are the different molecules, what are the metals in the ground, and then trace back the origin, try to suppress them. That work will move there. There's another one with the Egyptians are involved, and some more work on metal storage and balance in wheat. So this is looking at zinc-based fertilizers, which lead to faster growth, and this is the effect of concentrations of cadmium, which stunt the growth. Experiments are being done by a lady who's going to be in a movie I'm going to show in a few minutes, Zara Sayers. She's Turkish. She's carrying out this work in Hamburg at the moment, but it will move there. Now, the other beamline at the beginning will be the infrared beamline. Well, you don't learn much from that. Let's just go to the science. So infrared light, and when we're all radiating infrared light, when we have SESAME, we'll have really, really bright infrared light. And then to look at the samples, you need an infrared microscope, which you can see the infrared with it. And we realized you can also do experiments with the infrared microscope just using a hot wire as a source. It'll be much better when SESAME is built, but we thought, why don't we get one of these microscopes early so we can start having publications? So science has been going on, and the first person to publish was this lady here, Fatemeh Elmi, from Iran, who did a study of breast cancer. That's now published. And this is a Jordanian lady who looked at the effects of a medicinal oil, and that I discovered was published last week. And there's going to be further medical studies at SESAME. There's one genotype of hepatitis C, which is prevalent in the Middle East and in North Africa, but nowhere else in the world. So it hasn't been very carefully studied. But it's scientifically interesting. It's an area we're hoping to get some actually expatriate Egyptians in the US think maybe they can get National Institute of Health funding to work on this. This is just to show the next Beamline will have one of these things that put bumps in the road. That was given to us by the Swiss. It's sitting there waiting to be installed. Now the training program, vital. So there's been users meeting, schools, workshops, fellowships, visits to operating light sources, users meeting. I think we must be up to the 15th or 16th. I think every year there's been a users meeting. It was the users meeting which decided what are the beamlines we wanted. There have been schools. This is one funded by the Japan Society for Promotion of Science. It's another users meeting. These are the people you saw before. But that was at the beginning, training accelerator people, now turning to training the scientists. Now, when the scientists come to SESAME, they'll need somewhere to live, and we're building a guest house. All these labs, Brookhaven, for example, they have a guest house where the visitors come because they're coming for short periods. They want to work intensively. And anyway, if the Israelis are coming, they want to be in secure surroundings. But this is at all light sources, all accelerator labs. And that's where the human contact is made, and very educational. People are talking at the, over the coffee table and so on. This is a temporary building which we put up. It will house, I think, 7 or 8 people, while we're building a new one, which is being paid by the Italians. Now, this brings me to how this is being funded. So the members have always understood they have to pay the operating budget. You can't ask somebody else, please come and pay for us to do this. The manpower, consumables, electricity. Capital funding, special contributions that I mentioned, and from Jordan, has put more than anybody else. It provided the land and the building, cash from the Royal Court, and the Jordanian Scientific Research Fund is paying for one of the beamlines. From the outside, we had a lot of advice from experts, donations of equipment, and training. And here's the countries, the laboratories. I can't list them all here. Oh, by the way, I have got with me, if people really want to know more about this, for the opening ceremony, we produced a special brochure for the day, and it has details of the early scientific program, and it has a sort of honors board of everybody who's contributed, and I've got 3 of these. You're welcome to take them away. And cash from the European Union and Italy. The total investment so far, including the value of in-kind contributions, the value saved for SESAME, not their original value, is about $90 million. I doubt, in fact, I'm sure that nobody's ever built a synchrotron light source for $90 billion before, albeit without proper workshops so far, with only 2 beamlines, etc. But it's really remarkable. Now, an immediate question is, what about the USA? Have they contributed? And they've given a certain amount of help. But it's been a bit of a disappointment. In 2009 or 10, the US has been an observer since the beginning, and they send people who give advice and very helpful, and experts. In 2009 or 10, an advisory committee to the State Department, which is the US Commission on UNESCO, published a statement saying the success of SESAME is in the diplomatic interests of the United States, which I believe to be true, but as a foreigner, it's not for me to tell you that. Those are the words of an advisory committee to the State Department. Then in 2010, Obama, in his first year, made a speech in Cairo, reaching out to the Arab world, which contained a paragraph, actually written by John Holdren, the President's science advisor, which said that we will aim to foster centers of scientific excellence in the Middle East. And at the same time, coincidentally, I think, 5 members of the Congress, led by the 2 physicists in the Congress, Rush Holt, who is now the CEO of the American Association for the Advancement of Science, and Bill Foster, who's still in the Congress, 5 members of Congress wrote to Hillary Clinton, who was then Secretary of State, saying, pay attention, this is something where we could get some brownie points and get diplomatic benefit. What about giving $5 million? And since then, I've been many, many times, 4, 5, 6, I don't even remember, to Washington. And we've come, I thought last year we were close to getting support, but unfortunately it hasn't happened. I could go into more detail on the reasons it haven't happened, which some are political, there are other reasons. This is just a picture of some of the advisory committees. So you can see people from around the world who'd be willing to give their time to come and help. This is a bunch, we've had a lot of moral support of 45 Nobel laureates. I don't think that's the 45 who signed the agreement, who put out a statement that endorsing SESAME as a beacon demonstrating how shared scientific initiatives can help light the way towards peace. Now, I'm coming to something which really is a first for SESAME. Accelerators use a lot of energy, and they're much criticized for this. And for SESAME, this is a catastrophe, or potentially was a catastrophe. Having struggled to get the thing built, once I saw a couple of years ago, we are going to get it sort of built and operating, how the hell are we going to pay to operate it? Because in Jordan, we're paying 76, I think now, US dollars per megawatt hour. That's 37.5 cents. That's the wholesale price. Now in the US at the moment, that's, what is the price today? The wholesale price is around 3.5 cents. This is 37.5 cents. And this uses 10 gigawatt hours a year, so you can do the maths, that's $3.7 million a year. That's more than the total budget in 2016, which the members had great difficulty paying. So it was clear that we're not going to be able to operate this, but let's get it built first, worry about that later. And always had at the back of my mind, it's obvious we have to build a solar power plant. We've negotiated an agreement. It's not that we can only run SESAME when the sun's shining. That would be crazy. But if we give to the grid 10 gigawatt hours a year, they will give back to SESAME as and when needed 10 gigawatt hours. So that was agreed, and we thought we would go to what's called a build, operate, transfer contract. We'd find a company. I'm sure we could have found a company that says if you guarantee to buy this power from us and you help us get the permission and the land, and we can sell any excess power meanwhile, but if you guarantee to buy for 5 years, we'll give you this power for, I don't know, $30 or something. But we've done better than that. We're getting it for free, basically. The European Union has a program designed to reduce carbon emissions in neighbouring countries. And they've given something like 60 or 70 million euros to Jordan for this purpose. And the Jordanians, it was Khaled Toukan who negotiated this, the director, said, we will pass on 5 million Jordanian dinars, that's about $7 million, to SESAME to build a power plant. So it's not clear. If I'm in Europe, I say this is a European contribution because the money started in Brussels. But really, it's a Jordanian contribution because the Jordanians could have said, we will use that money to build a solar power to power schools, hospitals, government offices, and save the Jordanian taxpayer money. So they're paying the opportunity cost. So it's rather unclear when we say who's given us what, how we count some of these contributions, because there have been a couple like that. But actually, I should check up. We went out for tender in late April, and I think the closing date is about today. And if we agree a contract quickly, by something like February or March next year, we could have a solar power plant. SESAME will be the first accelerator in the world powered entirely by renewable energy. I think actually the only one powered by renewable energy, but I stand to be corrected. I don't know of any even with partial power. So that's something we're very, very proud of. It's a real world first. So let me come to the outlook and conclusions. There are ongoing problems, solving problems involving travel restrictions, still sanctions, political uncertainties. So this is probably a point to say something about the political difficulties, because there have been some. I mean, I mentioned that Egypt couldn't come because of the Arab Spring, but there have been more direct ones. It's quite difficult when we are having a council meeting at a time of particular violence in the region between the members. It creates great tension. So, for example, we were meeting in Cairo in June 2010 at a time when the Turkish government sent a ship with aid to Gaza to help the refugees, and Israel landed a bunch of commandos on that ship. They thought maybe it's not taking aid, and some people were killed. And that happened. We woke up in the hotel in Cairo, ready to go to the meeting, switched on CNN, and we'd all seen that news. So obviously there was some tension in the room. And there was a proposal we should condemn it, and no, it's political, we never discuss politics. No, it's humanitarian. Actually, that was calmed down, and half an hour later people were shaking hands again. But it's always there under the surface a little bit. Another big issue is what the Palestinians should be called, because if you talk about Palestine, that is construed as being recognition of the state of Palestine, which Israel won't accept, and nor will the United States accept. In fact, it's illegal for the United States to fund, under a law from the early 90s, any organization which recognizes the state of Palestine. So it's the Palestinian Authority which is a member. And in fact, Yasser Arafat signed the agreement on behalf of the PLO for the Palestinian Authority, something like that. But they don't like being called the Palestinian Authority. They call themselves Palestine. And when UNESCO, rather stupidly, recognized Palestine, which led to the US stopping paying, the US does not pay anything to UNESCO at the moment, which created severe financial problems for UNESCO, because the US was paying something like 28% of the budget. At that point, somebody said, hey, we were created under UNESCO, so just as an administrative act, change Palestinian Authority in all the Sesame Papers to Palestine, of which the Israelis start to walk out. That was an issue. We calmed it down. In fact, they then said, well, we don't really want the change, but they wanted a statement about it minuted, which was not in an acceptable form. On the other hand, if we look on a positive example, 1 year we were looking for a new vice president of the council, and there were two nominations, one of whom, I won't tell you the nationality, but was quite obviously unsuitable, and the other was an Iranian. And the Israelis said it's very difficult for us to vote for an Iranian unless we're sure that later they will vote for an Israeli. And if we can't get such an agreement, we will vote for this unsuitable character. So a huge act of shuttle diplomacy. We agreed that we would rotate the right to nominate, not necessarily to be elected, and we did in succession have an Iranian vice president and then an Israeli vice president. It was Eliezer Rabinovich, so that worked. And we had a bit of trouble, to one more example of political difficulties, and I've told you almost all of them actually, in 8.5 years, it's not so many. When we had the opening, a couple of the Palestinians didn't come. It was clear this was nothing about science, it was nothing about Sesame, because while telling me that he wouldn't come, the one who did tell me that he wouldn't come, he said, but I am coming to the council meeting tomorrow. So I think, and a lot of the Palestinians did show up and were quite angry that their colleagues hadn't come. But some of them interpreted this as a political occasion, which the rest of us thought was a scientific occasion. So that was rather unfortunate. And I was desperate that the headline in the papers was not going to be Palestinians boycott the opening of Sesame, which they didn't, in fact. There were a number there. But it was a rather tense moment because I was rather frightened that some of the ones who did come might stand up and try to make some statement. So there are always these difficulties hovering there. But the difficulties are there the closer you get to the political level. When we're at the purely scientific level, we do not see any difficulties. So we're still looking for funding. It's difficult to pay. New members. We'd love to have new members. The Gulf countries, if you ask them, why don't you belong, there's an organization called the Gulf, what's it called? The Gulf Collaboration Council, something like that. They have a mutual agreement. They won't join any organization with Israel in it. And they say it's impossible because Israel's in. Actually, I think for many of them, Iran's presence is equally difficult, but it's sort of more politically correct in the Middle East to blame Israel. But this may change, because the other reason they weren't in is at the beginning, most people said, this is never going to work. It's just not going to work. And I think now, if we go back and say, it is working. If you join, you can get science tomorrow. Actually, we're opening the doors for anybody to come and do science, and we hope that some of the countries that are not members will send scientists who will then lobby their governments, saying, we want to have our hands on this science, let us in. So I hope that will happen. But it is a working example of Arab, Israeli, Iranian, Turkish, Cypriot, Pakistani, hope I haven't forgotten anybody, collaboration. We're working together, sitting around the table, in Eliezer's phrase, with our neighbors, trying to do something positive. And the young people and senior scientists from the region are preparing for the program. And we put out the first call for Beamlines. We said we've only got 2 Beamlines, so we can't take many. It got 55 proposals, which we can't possibly accommodate. So that shows that we are not going to be lacking users, that's for sure. So this, just briefly, beyond SESAME. So some of you will know that in Europe, CERN was the first European scientific organization, but many others followed: the European Molecular Biology Lab, the European Radiation Facility, the European Southern Observatory, etc. And many were modeled on CERN, and many of them had their headquarters at CERN until the EMB, the Molecular Biology Lab, had offices at CERN until the site was chosen. And I have a dream that the same thing may happen with SESAME. Once we built this guest house, which we're just about to go out to tender actually, we will have, the guest house is already being built. We're looking for the funds now for a conference center. When we have in secure surroundings a conference center and a guest house, I'd like to think that we can invite people from the region to hold meetings when SESAME is under maintenance and not being used for science, say you can use these facilities for conferences about regional issues, food, water, archaeology, in secure and easily accessible surroundings. And my dream is this will lead to other facilities and collaborations. So to conclude, before I show you the movie, the construction of SESAME has been a victory of optimism and hope over skepticism and realism. I can point to 3 or 4 occasions when I've been involved where a rational person would have said, just give up. But that would have been such a negative message. You can't make it. And in fact, in my mind, the great thing about SESAME, it's going to do great science, it's going to bring people together, but I see it as an existence theorem. It shows that over some of the deepest divides in the world, not just between Israel and the Arabs, many of the countries there are in conflict, over the people with goodwill who want to reach out their hands and work together across divides can do so. That's why we kept going. And I think that's the message you'll get if I can find this movie. It's here somewhere. Let's get the movie showing, and I'll finish with this movie. How do I make it play? Hit this here, I guess.
This is something
how do I get it to full screen?
To next generations. This is what I believe.
It's okay like that?
It has to work because it means a better world. It means a better world from many aspects, in terms of bringing science here, in terms of bringing a line of communication. Maybe it will not bring peace to the region.
It is very valuable and it is very important for our region because one country cannot afford to have a single synchrotron machine.
Here we are as scientists, and scientists usually belong to the humanity, not to the country. I understand that there are some political use of science, but we are not here for political use of science. We are here for science.
The work we do here can be used in many fields, including electronics, including engineering, including material science. So it will have many applications from cement to health.
What we hope is that science will open the door to for other or further understandings concerning other issues. Okay, this is what we hope. I mean, we begin with science, and somehow we will open the doors that are closed for years or for centuries.
Iranian and Palestinians and Pakistanians scientists are my friends because they are scientists, so we have a common ground. The common ground is doing research. We don't care about what is your religion, what is the color of your skin. We don't care about that. We only care about science.
In science, there is no hostile. Okay, we are scientists. We are academic people. We are not dealing on political issues.
I think SESAME is a modern technology which helps to people around the Middle East to develop and improve their knowledge.
I imagine a war would bring it to a stop, but we've been pretty close to a war, or very high tension level in the last few years, and somehow we've managed to keep going.
It was always my dream to show that Arabs and Israelis can work together for the benefit of humanity and for the benefit of their own people. Both sides having an interest in that. And for me, SESAME, in a way, is an incarnation of such a dream.
Right, thank you very much.
We can entertain some questions or comments. Please.
Just to get some perspective on these machines, can you tell me how this synchrotron compares to the one being built next door, like in Brookhaven?
Yeah, so this is, as I said, there's about 50 of these devices in the world. This isn't the best, but it's certainly not the worst. I mean, it's quite difficult to characterize synchrotrons because there are two things involved. One is the energy of the accelerators that determines the wavelength you can get to, and hence the scale you can study things. So if you're only interested in the infrared, you don't need a very big machine. So this has a reasonable range. There are bigger machines that can get to harder X-rays and even shorter distances, but this is a pretty good range. And the other criteria is the brightness and the emittance. And that, again, is probably not going to be the best in the world. We don't know yet. Well, it won't be the best in the world, but it's competitive. I mean, the way I like to say it is that somebody with the right idea can get a Nobel Prize for this machine. And there is room for them. I mean, the other skepticism at the beginning was these people will never get it to work. And there was also a view there are enough of these machines in the world, which was a really stupid comment, I think, because, maybe somebody in Cairo, say, who's done a PhD in Europe at a synchrotron facility can still get accepted to do that, but the graduate student cannot. I mean, having their own machine that people can go to, they can control the program, is absolutely vital.
Two questions somewhat related. One has to do with, you said you have already a large number of proposals. Is there a program committee? How does that work? And the other is just a question given the citing of security.
Yeah.
What are the considerations there?
Okay, so first of all, there is a program committee, it's going to meet virtually, I think, and it hasn't yet looked at these because I was hoping we'd have the Beamlines working right now. It's going to be later this year. So they haven't actually, they've just distributing a couple of weeks ago these proposals and beginning to analyse them. But the chair is a guy called Samar Hasnain in Liverpool in the UK. He's a joint Pakistani-British citizen. And the other members of the committee, I've forgotten how many they are, but they're experts from around the world to begin with the expertise relevant to those first two beamlines. Now the security, that's going to be a big question to see who is going to be prepared to come. So the site is a secure site. It was finished installation of the security system about 2 weeks ago. You know, there's a very good security fence, there are CCTV cameras, there are guards there looking at the cameras and so on. But it's like all security, you know, clever people will be able to get around it if they really wanted to. I thought for the opening, I was quite nervous about the security, but there wasn't any incident that I know of. Of course, the king was there, so the army was all over the place. In fact, there was some doubt whether the king would show up. He doesn't like to go outside the palace to any meeting for more than half an hour. He stayed about 45 minutes in the end because it's known where he is. And the night before, some of the people were saying, we haven't seen enough security, we think he's not going to come. But driving down in the morning, it became pretty obvious he was going to come because of the army everywhere around the road. So security is a worry, but we just have to hope that people are prepared to come. And that's connected to another question that you asked me before, actually, George, which is about publicity for this project. So publicizing this project in Europe and is good because, you know, the European Union's helped us a lot and they like to be patted on the back, and by patting them on the back with the publicity they will help us some more. In fact, they've just agreed to fund another beamline, and the same with the Italians. I was in a meeting with Romano Prodi and the Prime Minister of Italy a few weeks ago, so they will give us more, and I hope this could help us in the US. There was an article in the New York Times about this project. In the Middle East, it's not so clear to me because you know, if it gets on the radar screen, there are people from the University of Cairo working with Israelis in Jordan. Somebody may jump up and say, why the hell are they doing that? Stop. So it may be best, we want to publicize this to the scientific community, but probably not get too high a profile publicly, because it could have a backlash. I'm just speculating, I don't know. But that's the feeling of some of the people in the region. So we have an outreach program, but it has sort of rather mixed objectives in different parts of the world.
Do all the researchers speak English?
Yeah, the language of SESAME is English. And in fact, it came up, as we were inviting ministers to the meeting, should we provide simultaneous translation and so on? And we said no. I mean, there's too many languages. I mean, you know, think of the religions, first of all. We've got Shias and Sunnis and languages. We've got Urdu, we've got Christians, and you know, we've got Jews and so on. But the languages are very diverse also. So it's just the universal language. And we said it's in English, and it was in English.
And Bessie, why was Bessie decommissioned in Berlin?
It was being decommissioned because it was, you know, the better machines were being built. It was also because it was soon after the reunification. Well, yes, it was just about that date. And there was a move as a sort of helping previously Eastern Germany and Berlin by putting new facilities there. So there was money around for new facilities, but we can build something better. So they gave us a facility. Which, by the way, we didn't use in the end, apart from the booster. And the way that small guest house was funded, we eventually said, we're never going to use some of the other stuff. There's a lot of scrap. And we sold it for scrap, and it built the small guest house.
Well, there are no further questions or comments. Yes, I can speak again.